Go back. Right on the money. That did the foot come out? I think it probably came.
Hello everyone, myself Sanmitra Bhaumik, and today we have a slightly different topic, different from regular academics, that is regarding the physics behind Dhoni's unrealistic stumpings. Yes, you heard that right, we are talking about MS Dhoni, the former Indian captain. Everybody is aware of Dhoni. He is also nicknamed as the Captain Cool. Dhoni is such a big name that he needs no introduction. We know the Dhoni the batsman, Dhoni the captain, but what often gets overshadowed by his batting prowess, that Dhoni the wicketkeeper. Dhoni the wicketkeeper did not start as he is of the legendary status today. He was just a wicketkeeper who could bat very well. That was the main criteria why he was in the team. And his wicket-keeping techniques are very unconventional. I will discuss that later. Why it is unconventional, and it was not considered proper wicket-keeping technique in the initial days of his career. But he made that unconventional technique into a completely different genre of wicket-keeping. His new style of wicket-keeping made him possible to perform lightning fast stumpings. So today we will be talking about Dhoni the wicketkeeper and not the batsman and the captain. Although there can be a separate series of video appreciating his achievements as a batsman and as a captain.
This will tell us.
Might not. The umpire's in the way. Might well be in the way.
Okay, let's begin. So let us start by the definition of stumping. For those of you who are new to the cricketing circle or those who are not that much familiar with cricket, stumping is a form of dismissal in cricket when the batsman, while attempting to play a shot, is unable to return back to the crease and the bails are being taken off using the ball by the wicketkeeper. So, the batsman is unable to make his ground after playing the shot, and the wicketkeeper takes the ball in his hand and puts the bails off. We have seen this a lot of times. This is a very normal mode of dismissal. But what is special about Dhoni is that the speed at which Dhoni stumps the batsman, that is magnificent. Within the blink of an eye, the batsman gets stumped. The batsman hardly gets the time to return back to the crease. But what is so special in that? Why are we even discussing this? We'll come to know. Okay, so what is special about MSD? MSD or MS Dhoni has extremely quick stumping, can perform extremely quick stumping, and you can see his reaction time 0.08 second, 0.09 second. You can Google how much time it takes to blink an eye. Such fast is his reaction time. So all 5 records belong to MS Dhoni. So fast he is. Okay, so where does MS Dhoni stands in the area of stumping? Like MS Dhoni has the highest number of stumpings by a wicketkeeper in ODIs. That he has 123 stumpings in 350 ODI. And the second best is Kumar Sangakkara, who is also a legend. He has 99 stumpings in 404 ODI. And the rest of the stumping records are given. So definitely he is already at the top. But how could somebody with an unconventional technique be at the top, reach the top of the wicket-keeping charts? Let's find out. But why are we talking about this? First of all, there are a few people who claim that Dhoni's stumpings are against the laws of physics. They defy the laws of physics. But this is not true. They are just the excellent application of the laws of physics in an alternate manner. What the textbook suggests or the coaching manual suggests, he does that in a different manner. But that doesn't mean the laws of physics are violated. This can be called as out-of-box thinking. and what is unorthodox is not always wrong. And this video is important for every cricket lover and physics enthusiast, and every student while watching cricket now can relate what they are learning in the textbook with what they are seeing on the field. Let us talk about the other greats of wicket keeping. We have here Gilchrist, we have Sangakkara, we have Mark Boucher. These three are also great wicket keepers like Dhoni. In fact, the best wicket keepers of the world along with Dhoni. But all these three wicket keepers follow the conventional techniques of wicket keeping, and all of them established a place in the wicket keepers list before Dhoni arrived into the picture. So, but Dhoni followed his own techniques, followed his own set of skills, and still is able to match with these greats. So enough about Dhoni and other wicket keepers. Now let's see what is the wicket keeping technique, and how is physics involved in this. Okay, let's talk about the conventional technique. The keeper collects the ball while moving his hands backward. That means while collecting the ball, when the ball is coming to his hands, his hand is also moving backward. Why I am telling you? This reduces the impact of collision between the ball and the gloves. I'll tell you why. Used by almost all great wicket keepers and prescribed by the coaching manuals. Okay, so we can see a glove and the ball is coming towards the gloves. See, the ball is moving backward towards the wicket keeper, and the wicket keeper's hands are also moving backward. The ball is moving with a velocity v, which is generally around 90 kilometers per hour for, say, a spinner who is bowling a little bit faster. And the wicket keeper's hands are also moving backward with certain speed, that is Vg, the velocity of the gloves. Now, this conventional technique makes use of the first law of motion. Correction, the second law of motion. Second law of Newton's second law of motion, that states the force is equal to rate of change of linear momentum. That means the change in momentum, that is the ball is having some momentum, linear momentum, and the hand is having some momentum. If the hand is at rest, its momentum is 0. The direction of the velocity of the ball changes. The ball's velocity will become 0, and again, while dislodging the bails, the ball's velocity will be exactly opposite. See, del P by del T. Del P is the change in linear momentum and del T is the time. Del P is PB minus PG. I'll tell you what is this. Now, the hand is also moving backward and the ball is also coming. Both are in the same direction. So if you find the net change in momentum, what happens is that the ball is moving with a speed Vb, and after the wicketkeeper collects the ball, then the ball will move with the speed of the gloves. That means the ball will match the speed of the gloves. So instead of coming suddenly at rest, the change of velocity of the ball will be lesser. And also we can see a del T term, that time del T will be larger. So that will reduce the impact of collision. See, the velocity becomes 0 after collecting the ball. But what happens is that the distance also increases. While the deacceleration of the ball from Vb to 0, it consumes some distance. So the distance is greater than what it was earlier. Now, this technique is advantageous because it allows the stable collection of the ball. That means there is very less chance that the ball will slip away from your hand, because you are just collecting the ball in a stable manner. And after you are in a stable position, then the wicketkeeper will stump the batsman. Then the wicketkeeper will move his hands forward and try to stump the batsman. This is the conventional technique as prescribed in the textbooks. But now let's look at Dhoni's technique. What does Dhoni do? Dhoni.
Did he get to, he's out there for sure.
Whoa. It's all an anticlimax because of Dhoni's way of doing it out. He got him easy. Smart work from the Indian captain.
When the spinners are bowling, actually Dhoni is also called the spinners captain because he manages his spinners very well. So, and he also advises the spinners how to bowl and where to bowl. This is more of a cricket talk than the physics talk. Okay. Now when the spinner is bowling, that time Dhoni anticipates after bouncing off the pitch at which direction the ball will move. So he anticipates the path of the delivery. Why he does it, we'll know. Now, as the ball is coming to the hand, the other wicket keepers will move their hands backward. Instead of moving back, Dhoni will move his hand forward in the direction of the incoming delivery. Let's see. The ball is coming, the batsman has missed the ball and the ball is coming towards the wicketkeeper, and the wicketkeeper is moving his gloves towards the direction of the ball. So the direction of the velocity are opposite. So what happens is that initially the ball is having some momentum, that is mass of the ball into velocity of the ball, mb into vb. What is the final velocity of the ball? It will not become 0. Rather, it will not even be in the same direction. Rather, it will be in the opposite direction with the speed the wicketkeeper is moving his gloves. So, what is happening is that I have written F is equal to del P by del T. That is the Newton's second law of motion. The time of collision, I mean the impact of the collision will be very high because the time taken to affect the change of the velocity or the change of the momentum, that is very less. Therefore the impact will be of several times. But what is the advantage in this method? Why he does that? See, I have shown here del P is equal to del B plus del G. Now, the advantage is that the wicketkeeper will collect the ball at a distance very close to the stump. So he gets that extra time. I mean, he gets that extra time to stump the batsman because he has to cover less distance now. And already he is in the motion. He is already in the motion with a velocity of Vg, that is the velocity of gloves in the direction of the wickets, direction of the stumps. So he will just continue to move in that direction to take the bails off. So what are the advantages? That is, we'll get faster stumpings because he's moving, he's already in the motion and less distance to cover to reach the stumps. So this is a fantastic method as it looks. But wait, what looks easy isn't easy. We see Dhoni stumping out batsman within the blink of an eye, but that is not that easy as it looks. Then why are other wicket keepers not able to replicate his techniques? He's already there for 16 years. But why are other wicket keepers not able to do what he's doing with such a speed in a regular fashion? Because there are some certain difficulties. First of all, the collection is not stable. When the gloves are moving in the direction of the ball instead of moving backwards, the impact is so high that the ball may slip out. You cannot collect the ball in a stable fashion. And the impact of the collision is also several times higher than the conventional method. So it is difficult to do it all the time. And also requires higher reflexes and hand-eye coordination. And also due to the impact, the hands must be tough. it is not easy to do it. It is not easy for a rookie wicketkeeper to do it, and it requires higher reflexes and hands-eye coordination. Otherwise, you won't be able to intercept the path of the ball, because the ball is coming not at a very slow speed, but say 85 to 90 km per hour. That is really, really fast. But Dhoni made it his mastery. It is his piece of cake now. As it looks to us, it is actually to him. Because, as I said earlier, Dhoni wasn't the best wicketkeeper in the country when he arrived on the big stage. He was selected mainly for his batting skills. But as I said, as I have written here, perseverance is the key. He practiced and practiced, and he believed in himself. He mastered his skills by practicing, and today he has proved everybody wrong. And youngsters are trying to replicate his style of wicketkeeping nowadays. So that's all for today. I hope you liked our video, and now you will be able to appreciate how physics can be applied to real life. Like, even while watching sport, you can think of what you have studied in the textbook, and you can mentally apply that. And thank you, MSD, because of his contributions to the nation. He has made India proud, really. If you want us to make similar video, then please comment below. Thank you. And please like this video and subscribe our channel if you find this content useful.
Stretch right forward, losing his balance as he played, and that looked certainly as if he couldn't get his foot back.